So this is a video on the mean absolute deviation. I'm not going to explain what the mean absolute deviation is. I'm just going to explain what I've done. And you're going to have to pay attention quite a bit because it's a little bit crazy. I had a hypothesis. My hypothesis was this, that my mean average deviation, or absolute deviation, I should say, mean absolute deviation, if I were to roll 2 dice, would be smaller than if I rolled a 12-sided die. So here's what I did. On Excel, I did random between 1 through 6 for die 1, and then I did random between 1 through 6 for die 2. And what's kind of neat about this is, if I were to change, if I do this, you'll see that it changes. It will change the values, but it'll always give me a value between 1 and 6. And then I copied it 100 times. The next thing I did was I added die 1 plus die 2. So you can see this cell plus this cell equals 7, 3 plus 3 equals 6, etc., etc. Over here, I found the average of the 2 dice. So right now, the average is 6.676768. What I then did was I found the difference between my sum and my average. And for here, it's 0.32 repeating. I did that again over here. And what I did is, if you look at my formula, it says equals abs D2, which is my sum, minus E2, which is my average. So abs means absolute value. So it always gives me the absolute value. So they're all positive values. I then found the average of the differences, and that gives me my mean absolute deviation. Now, my hypothesis is this. My mean absolute deviation should be smaller for these 2 dice than it would if I just had a single 12-sided die. So what I did was I did random integer between 1 and 12. And the first one was 3, then 5, then 3, then 8, then 6. And I did this also, if you go down, you'll see I did it 100 times. And once again, this is kind of neat because if I were to change it even a little bit, it changes. So the nice thing about using this program is that I can do 100 trials over and over and over repeatedly and take a look to see if it was just once, it might be a fluke, but if it's more than once, probably not a fluke. So then I found my average, which is right here, of the 12 dice, and to do that I wrote equals average of H2, which is H2 right here, all the way down to H100, and I found the average. And then to find the mean average deviation, so here's my average, I went to here, and I took the difference between H2 and I2, and I get that, and then once again, I found the average of my differences, which is the mean absolute deviation. Now, over here in these multicolored columns or tables, you'll notice I have 1 through 12, and then I have 1 through 12 here, and it says 2 dice. Now, no matter how many times I do this experiment, I'll always only end up with 0 for my 1. Always, always, always. And the reason why is because there's no way for me to get a 1, because I'd have to roll a 1 here and a 0 here, or a 0 here and a 1 here, and I obviously can't do that. So this is always going to be 0. But the rest of these count up. And once again, I use the formula equals count if, and I said D to D, and it says 2. So if anything in the D column is a 2, it counts it. If I count, here's D to D, and it's 3, so 3 counts it. And then I did the same for my 12-sided die. Now, the very first time I do this, I end up with a mean average deviation of 2.1 and a mean average deviation of 3.2. So right now my hypothesis holds true. So I'm going to do it again. I'll run another trial and we'll see what happens. Here I get 1.99, here I get 3.08. Well, that could just be coincidence that happened twice, but remember, I'm doing this with 100 trials every time. Once again, it's 1.7. So far, my, I just did something I shouldn't have done. so far it's holding true. Holds true again. So let's take a look at the graphs. And here's what I'm doing. I'm looking at what am I actually rolling. And let me flip-flop these. With two dice, you'll notice, you should notice, that I've got this bell curve. And this is a really, really good bell curve. And take a look at number 7. Number 7 happens like what, 22 times? Number 6 happens 15. Number 8 happens probably 12. Number 2 happens 3 times. Number 12 happens twice. But over here, these are a lot more uniform. I'm not going to say they're in a straight line, but I have an equal chance of rolling 1 as I have rolling a 12. And I have the same amount of chance of rolling an 11 as I do rolling a 2. Well, here I have the same chance of rolling 11 as I have rolling a 2, or a 3 rather. But why does the 7 come up so often? And to get an idea as to why the 7 comes up so often, it's important to take a look at this. These are all of the possible ways to roll a 7. Well, to roll 2 dice. The first number represents the first die. So I could roll a 1 and then a 1, or a 1 and a 2, or a 1 and a 3, and a 1 and a 4, and a 1 and a 5, or a 1 and a 6. And the second number represents all the ways of rolling a second die. So in order to roll a 2, I would have to roll a 1 and a 1. Well, that makes sense, but then the problem is there's no other way to roll a 2. And the only way to roll a 12 is to roll a 6 and a 6. And that's it. Those are the only 2 ways to roll a 12. Now, if I want to roll a 7, I could roll a 1 and a 6, a 2 and a 5, a 3 and a 4. Oops. Oh, you know what I should be doing? I should just use my pen for this. A 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. So there's 1, 2, 3, 4, 5, 6. There's 6 different ways of rolling a 7. If I want to roll a 5, not a 7, a 5 or a 6, I could do it, let's see, I could do it 1, 2, 3, 4, 5. So there's 5 ways of rolling a 6, which is fewer than the number of ways of rolling a 7. How about rolling an 8? 1, 2, 3, 4, 5. So to kind of give you an idea, there's 1 way of rolling a 2. There's 2 ways of rolling a 3. 3 ways of rolling a 4. 4 ways of rolling a 5. 5 ways of rolling a 6. 6 ways of rolling a 7. But then it starts going, where are those numbers? It starts going back down again. And I think is interesting about this is if you were to draw it using a bell curve, you would notice that it would look something like this. And I mean, obviously this is very rough. Oops, there's only, yeah, 2 and 1. And that's exactly what we had. So, whereas these all have the same equal chance of getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 1 way you can get all of them. So now let's take another look at this. When I change it, look at this. This time I had 0 2s. But here, it still remains, I'm not perfectly straight across, but you can see the bell curve still here, and my mean average deviation is still lower for my 2 dice than it is for my 1 die. Still lower, bell curve kind of still exists. This one's a little bit of a wave. And it's not going to be perfect every time, but so far I have not been proven wrong. Bell curve still kind of exists, a little bit weird with that 5. But my mean average deviation is still lower. So why this is important, why the mean average deviation is important, is because it means that we found that our average was 6.88. And it means that the average distance away from the mean on our rolls is only 1.7, still very close, and that's because of this bell shape. Here, my average is still 7, which kind of makes sense because 2 plus 12 is 14, 11 plus 3 is 14, 4 plus 10 is 14, and you divide by 2, and you always get 7. So it makes sense, but because there's nothing to hold back the 1s and nothing to hold back the 12s, our average deviation is nearly 3. It's 1, 2, 3. It's within 1, 2, 3. 3 units from the mean. And that should make sense because you still have a bunch of numbers that are inside that group. What's 3 units outside of the mean? 1, 2, 3. Oh, that's interesting. And 1, 2, 3. Yeah, well, that shouldn't really surprise anyone. Let's do one more and let's see what happens. Oh, glad I didn't fail. Once again, our average is 6.6, still follows the bell shape, and it's 2 units. 1, 2, 1, 2. And that makes sense because most of the values should fall very, very close to our mean. Here, my mean is 6.6, and it's, once again, it's nearly 3. 1, 2, 3, 1, 2, 3. Yeah, there's a huge range. So that's it. I'm actually quite proud of this video. I hope you guys enjoyed it, and I hope it does make sense. It's a hard topic to grasp, but that's the mean absolute deviation.